first, let me show you what Schlieren photography is, and then I'll show you how it works to the best of my ability, and we can discuss it, and I've got a few demos for you too. If you haven't seen it before, this is pretty cool. So let me turn the camera around here. And folks on the phone, do you see the screen, the monitor screen here?
Yep, I see it.
Yep.
So I'll move this speaker a little. And what we have here is a telescope mirror and a camera with a special setup so that any diffraction due to variations in air density show up as light and dark areas on the screen. And here's my hand, and you could see the heat coming off my hand on the screen. Can you see that?
Yep.
Yeah.
Looks like you have flames on your hand.
Yeah, that's why I like using an orange LED. So, but you could actually do this with 2 different color filters and get different effects as well. And it's more striking with more heat, obviously. So here's a lighter, and you could, oh man, it wasn't lit. That was just the fuel. So you can see the flame, and it doesn't just work with heat. We'll get something cold out of the freezer here. I've got your standard general issue frosty mug, and you can already see the air flowing off the outside of the mug. And I could even pour cold air out of the mug through the display, and you could see that airflow coming out of there.
That is awesome.
Yeah, it's always fun. I could just, every time I get this set up, I play with it, play with it, play with it. And you may even see while I'm speaking other heat waves come through the field of view. It's because this whole apparatus is set up right over the laptop that's running it. So let me show you how this works. Yeah, okay. So we have a light source, which is just a 9-volt battery with a resistor and an LED on it. It was part of my Workshop 88 LED tester. And that shines a light into a telescope mirror, a precision ground spherical mirror. And that light comes back and it is focused on a point right in front of the camera. And the whole idea is that that light fills the field of view of the camera. The light itself is not in focus. You want the subject out in front of the mirror to be in focus. And then a razor blade right at the focal point in front of the camera blocks half of the light. And this is actually 2 times the focal length of the mirror away, the way the geometry works. And what happens is that half of the light is being blocked and half of the light is making it through, but it all fills the field of view. But when something gets between the razor blade and the mirror, it allows the light rays, the difference in air density, allow the light waves to be diffracted just enough to make it around the razor's edge or to hit the razor, which leads to that really bright and dark pattern of due to the air density changes. And if you notice, it tends to be brighter on one side and darker on the other because of the orientation of the razor. And I'm not sure if you can see that. I mean, it's about as close as I can get with the cords I have. So, and I mean, as far as a kludge setup, I mean, who has seen a camcorder recently? I think you can do this with a cell phone with its camera and its LED light, but it was difficult for me to use that to do this experiment. I prefer to have these discrete items on the table so I could use my phone to take pictures of them and send them to my friends. But that camera is hooked up to this ancient laptop because it's an old laptop that runs XP, and I only have a FireWire live video feed out of that camera, so that led to using the laptop, which led to using this VGA monitor for demonstration purposes.